Hello students, class 10 science chapter 4 carbon and its compounds. In this video we are going to discuss about hydrocarbons and their classification, alkane, alkene, alkyne and isomers. First come to what are hydrocarbons? Compounds consisting of only hydrogen and carbon atoms are called hydrocarbons. That is only carbon and hydrogen. These type of compounds are known as hydrocarbons. They are classified into two categories: saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons contain carbon-carbon single bonds and these are known as alkanes. Okay. Unsaturated hydrocarbons are those hydrocarbons which contain carbon-carbon multiple bonds. And as we know, multiple bonds are double bond and triple bond. If there is a double bond between carbon-carbon, then these are known as alkenes. And if there is a triple bond between carbon-carbon, then these are known as alkynes. So simply we can say hydrocarbons are alkanes, alkenes and alkynes. Alkanes are saturated hydrocarbons and alkenes and alkynes are unsaturated hydrocarbons. Unsaturated hydrocarbons are more reactive than the saturated hydrocarbons. First come to the alkanes. These are saturated hydrocarbons, carbon-carbon single bond is there and these are normally not very reactive, so they are known as or called as parabens. This is a Latin word meaning param, that is little. Affines means reactivity, little reactivity. That's why alkanes are known as parabens. Their general formula is CnH2n plus 2. Okay, where N may be 1, 2, 3, 4, 5, 6 and so on. If we put N is equal to 1, then we will get the molecular formula of its first member, that is CH4, and its name is methane. If we write its structural formula, then this is carbon, and as we know valency of carbon is 4, that's why 4 hydrogen atoms are attached with a single bond. Okay, and this is the electron dot structure of this methane. Clear? Now if N is equal to 2, then we will get the formula of next member, that is C2H6, and this is called ethane. Then how can we write the structure of ethane? First, link the carbon atoms together with a single bond like this. Carbon-carbon single bond. Then use the hydrogen atoms to satisfy the remaining valencies of carbon. As we know, carbon has 4 valency and 1 valency of each carbon is satisfied by this single bond. Then we can say each carbon is linked with the another 3 hydrogen atoms with a single bond. In this way we will get the structural formula of ethane, and this is the electron dot structure of ethane. Okay, that is each hydrogen atom contribute 1 electron and carbon atom also contribute 1 electron in this single bond. Okay, this is a single bond. IUPAC nomenclature of alkanes, and we will discuss the straight chain alkane. I think you are familiar with this term IUPAC, International Union of Pure and Applied Chemistry. According to this, there are two parts of a straight chain alkanes. One is a root word and another one is primary suffix. In case of alkane, primary suffix is N, A-N-E. Root word indicates number of carbon atoms present in a straight chain. Okay. Now, if number of carbon atom is 1, then we use this meth. This is 2, 8, 3, prop, 4, but. If 5 carbon atoms are there, then root word is pent. For 6, hex. For 7, heft. For 8, oct. For 9, non. For 10, dec. Okay, and if we put this value of N into this formula CnH2n plus 2, then we will get the molecular formula of these alkanes. If N is equal to 1, this is CH4 and this is methane. If N is equal to 2, this is C2H6 ethane. This ETH, this is a root word for 2 carbon atom, and ANE is the primary suffix for alkane. This is propane C3H8, butane C4H10, pentane C5H12, hexane C6H14, heftane C7H16, octane C8H18, nonane C9H20, decane C10H22, and so on. Now, structure of alkanes like propane C3H8. There is a, first of all, from this again this formula CnH2n, we can say that this C3H8 belong to the alkane, and there is a single bond between carbon-carbon. That's why first single bond between carbon-carbon and satisfied remaining valency of carbon with hydrogen. Now this carbon attached with the 3 hydrogen atoms, and this middle carbon atom attached with the 2 hydrogen atoms, and this again terminal carbon atom with 3 hydrogen atoms. And in the condensed form, this can be written as like CH3, this is CH2 and CH3. This is propane. Okay. In the same way, butane C4H10, 4 carbon atoms in a straight chain link with the single bond, and remaining valencies of carbon are satisfied by the hydrogen. Okay, and this can also be written as like this is CH3, CH2, CH2 and CH3. Okay, in the same way, next member is pentane C5H12. This is its molecular formula. Hexane C6H14. This is its structural formula. Okay, actually these are the names, IUPAC names. These are molecular formula and these are the structural formula. Clear, student? Now again take another look at butane C4H10. If we make the carbon skeleton with 4 carbon atoms, we see that 2 different possible skeletons are. Now this is, one is in which carbon is linked in a straight chain with a single bond, and another one is there in that 3 carbon atoms in a straight chain, and in the middle carbon atom this is a branching. Okay, this may also be written like this: 3 carbon atom in a straight chain, and the middle carbon atom this is a branching. Student, remember that branching will not be at the terminal carbon atom. Like if you write this structure in this way, there is a no branching. If you write this structure like this, no branching, all these are considered as a straight chain compounds. Okay, this is also the straight chain compound. You can also write this is C. Again there is no branching, this one no branching is there. But when you go from this, you reach at this place, then again you have to think, you have to go this side or this side. That's why we can see this carbon atom has branching, and all these are this one, this one, this one, and this one. All they represent the same carbon skeleton. Is it clear? That's why for 4 carbon atoms, only 2 possibilities there. One is this one and another one is this. Now remaining valencies are satisfied with the hydrogen, then we will get this one, and this is called normal butane, and this is called isobutane. This may be also written like this. This is CH3. If you write in the condensed form, then this may be written as like this: CH3, this is CH, then this is CH3, and this is CH3. This is isobutane. Both these structures have the same formula C4H10. but their structures are different. Okay, that's why compounds with identical molecular formula but different structures are called structural isomers. In this way, we can say there are two structural isomers of formula C4H10. That is, one is normal butane, another one is isobutane. Now come to the structural isomers of C5H12. That is 5 carbon atoms in a straight chain. Remaining valencies are satisfied by hydrogen. Then we will get the normal pentane. In the condensed form, this will be written like this. Another possibility, this 4 carbon atom in a straight chain, and on this carbon atom, this is a branching. Or you can also show branching on this carbon atom like this. This is C, C. You can also see this is the branching. Okay, this one and this one, both are the same compound. Remaining valency should be satisfied by hydrogen, and then we will get this is isopentane. So this is its condensed formula, CH3 CH CH3 CH2 CH3. And this you can also write this in another way. If this branching is on this carbon atom, then you can say this may be CH3, this is CH2, this is CH, this is the branching on this carbon atom CH3, and this is CH3. But again remember, this one and this one both are the same compound, isopentane. Next one is, if 3 carbon atoms in a straight chain, then 2 carbon atoms on this middle carbon atom we have to add. This is one and this is another one. Again, satisfied remaining valency of each carbon with hydrogen atoms, then we will get this. Okay, neopentane. Its name is neopentane, and neopentane can also be represented like this. That's why we can say the formula C5H12 has 3 isomers: normal pentane, isopentane, and neopentane. Now next, alkenes. This is unsaturated hydrocarbon, contain one or more carbon-carbon double bond. General formula is CnH2n. Okay. If we put n is equal to 1, then we will get this formula CH2. This is unstable and does not exist. That's why the first member of alkene will be, when n is equal to 2, we will get the formula C2H4. And in IUPAC this is called ethene, but in common name this is called ethylene, and this is the first member of alkene. How can we write its name ethene? Again same pattern. First we will write the root word and then we will write the primary suffix. In case of alkene, primary suffix is ene. Okay, then we can write the structure formula like this. First make a double bond between carbon-carbon, then satisfy the remaining valency of carbon with hydrogen. Again remember, valency of carbon should be 4. So this is 1, this is 2, and this is 3, and this one is 4. Okay, this can also be written like this: CH2 double bond CH2, and this is the electron dot structure of ethene. Now next member, if we put n is equal to 3, then we will get C3H6, and its name is propene. How this is propene? Because first of all, this C3H6 satisfied this formula CnH2m. That's why this is alkene. Number of carbon atoms 3. That's why prop, root word, and ene. This is a primary suffix. Okay. Then if we write its structure, again there are 3 carbon atoms. Between any 2 carbon atoms, you can make a double bond. Like these are 3 carbon atoms. In first 2, double bond is there, and in this single bond is there. You can also write like this: first is the single bond, then you can make double bond. Remaining valencies are satisfied by hydrogen. So we can say on this carbon there will be the 2 hydrogen atoms. On this middle carbon atom there is only 1 hydrogen atom, and on this terminal carbon atom 3 hydrogen atoms are there. The same way you can also write both the structures, that is this one and this one, represent the same compound, that is propene. CH2 double bond CH CH3, or it may also be written as CH3 single bond CH double bond CH2. Clear, student? Now come to alkynes. Again, these are the unsaturated hydrocarbons. They contain one or more carbon-carbon triple bond. Okay, and their general formula is CnH2n-2. Okay, again, its first member N is equal to 2, C2H2. This is called ethane in IUPAC system, and in common system this is known as acetylene. Okay, then again, how can we get this name? Root word for two carbon atom, that is ETH, eighth, and YNE is the primary suffix for alkyne. That's why this is ethane. Okay, how can we write its structural formula? Make triple bond between carbon-carbon atoms, and remaining valencies are satisfied by hydrogen atoms. Okay, and this is the electron dot structure of ethane. There is a triple bond between carbon-carbon. If N is equal to 3, then we'll get the next member C3H4, that is propane. Again, how can we write its formula? First, you can make 3 carbon atoms. Between any 2 carbon atoms, you can make a triple bond, and then another, there is a single bond. You can also write this one. These are the 3 carbon atoms. Okay, and you can make triple bond here and single bond here, and remaining valencies are satisfied by hydrogen. Then we will get this one, either this or this. Okay, this may also be written like this: CH3C triple bond CH. This is alkynes, or this is the particular example, propane. Now, ring or cyclic compounds. We already discussed the carbon show the property of catenation. In this way, it may be straight chain, branch chain, or ring compounds can form by the carbon. You can say this is cyclopropane. Okay, there is a single bond between carbon-carbon, but all these carbon atoms in a ring structure. That's why we use the word cyclo. 3 carbon atoms, single bond, Ane. Okay, this may be represented like this. Okay, and if we write its complete structural formula, we will get this one. If there are the 4 carbon atoms, then we can say this is cyclobutane. Cyclobutane. If you write the molecular formula of this cyclopropane, then this will resemble with the alkene, that is C3H6. In the same way, cyclobutane, its molecular formula will come C4H8, but this is a cyclic. Okay, that's why there is no double bond, there is a single bond, that's why Ane, and this is its structural formula. In the same way, this is cyclohexane, that is C6H12. Okay, don't be confused with the alkene and cycloalkane. Okay, in case of alkene, if this is a straight chain, then there will be double bond, but if we make in a ring structure, then this is like there is a single bond. This may also be written like this, and this is the complete structural formula of cyclohexane. And again, see, this is the electron dot structure of cyclohexane. Try yourself and practice for such type of formulas, such type of electron dot structures. Clear? Now see, this is the one, benzene, C6H6. Actually, this is an aromatic compound. This is a special class of organic compound, and this term, this is coming from aroma. Aroma means smell, fragrance. Okay, benzene and its derivatives have special smell. That's why these are known as aromatic compounds. These are cyclic in nature, and in the benzene there is this alternate single and double bond. You can see from this structure. This is cyclic. That's why there are the 6 carbon atoms in a ring. Okay, this is 1, 2, 3, 4, 5, and 6. Alternate double bond and single bond. If this is double bond, then this is a single bond. Double bond, single bond. This is double bond, single bond. And remaining valency of carbon satisfied by hydrogen. Okay, you can also make double bond like this. In this case, double bond is in between these 2 carbon atoms. Now, in this case, double bond between like this. Okay, and this benzene is also represented like this, or in a very simple way, benzene is represented like this. Okay, I think whatever the topics we have discussed in this video, you have understood. Subscribe my channel to get the new video. Thank you.